Hi, everyone. Today we're going to dive into a highly technical topic, but one that will absolutely double your AI productivity: how Claude actually remembers your projects. A lot of tech influencers hype up massive 200 key or even 1 million token context windows, but as a product manager or developer, you've definitely experienced this frustration. Yesterday, you taught Claude your company's coding standards, and today, in a new chat, it forgot everything. This is actually the biggest lie in AI. MIT Technology Review calls this context loss and considers it the greatest limitation of current AI coding assistants. Why? Because the real project background and architectural decisions often only exist in your head. Having to re-enter this every single time creates a massive communication overhead that drastically slows down team efficiency. So, why do we desperately need a persistent memory mechanism? Traditional AI interactions are stateless. It's like having an intern who gets amnesia every day. You have to reteach them the company's name and who the clients are every single morning. In real workflows, what we actually need is a veteran employee who grows with the project and accumulates experience. To solve this problem, Anthropic introduced a dual-layer persistence architecture. The first layer is Claude Projects, independent workspaces for everyone. The second layer is the Claude Code automatic memory system, tailored for technical professionals. Through these two mechanisms, AI finally has long-term working memory. Let's first look at the top layer, Claude Projects, which is the most accessible to everyone. Imagine a project as a dedicated war room set up for a specific task. Every conversation that happens in this room shares the same set of background knowledge and behavioral guidelines. You don't need to reintroduce yourself every time you walk in the door. The AI is already prepared. A project is built on three main pillars. First, custom instructions, which set the AI's role and rules. Second, the project knowledge base, where you can upload architectural docs or core code. Finally, the multiple independent chats that unfold based on this background. Together, these three build a persistent context environment. What happens when your knowledge base files pile up and approach the 200K token limit? On paid plans, Claude seamlessly enables RAG, retrieval augmented generation. Instead of memorizing every single word at once, it retrieves information on demand, which amplifies the effective capacity by nearly 10 times. Let's test, everyone. What's the difference between the files you upload in the project settings versus the ones you drop into the chat box? Pause. The answer is C. The project knowledge base is persistent. Every new chat can see it, but files uploaded in a single chat only exist in that specific conversation. Once you close it, they're gone. That was the web interface. Now let's move down to the second layer and look at the deep memory mechanisms designed specifically for technical workflows. As developers, we constantly use Claude Code in the terminal. In this environment, we need a memory mechanism tied directly to our local code base. This is exactly where CLO UWSURAID model and auto memory come into play. The first mechanism is the cloud.bind file. Think of it as the project's employee handbook. Drop it in your project root directory, and Claude will read it first every time it boots up. It's packed with your team's architectural decisions, coding standards, and common commands. These are the rules you explicitly tell it to follow. The second mechanism is much smarter: auto memory. When using Claude Code, you don't have to write documentation manually. If you correct a mistake in a chat or show a certain preference, it quietly notes these learnings in the background, saving them locally to a memory polyLND file. So, whose rules does it follow when instructions conflict across different places? Claude has a strict loading hierarchy. It looks at global managed policies first, then user-level configs, followed by current project rules, and finally path-specific rules for particular file types. It layers these on to ensure it's doing the right thing in the right context. We've covered the concepts, but how do we actually use this in our daily work? This brings us to an advanced concept: friction-driven optimization. What exactly is friction? Friction is the gap between the result Claude gives you and the result you actually wanted. For instance, it used 4 spaces, but you wanted 2. That clunky, off-track feeling is friction. What most people do is just scold it right there in the chat. Wrong. Change it to 2 spaces, and it does fix it. But tomorrow, you open a new chat and it reverts right back to 4 spaces. Every time you make a manual correction without saving it down, you are throwing away a valuable data opportunity. The pro move is, when you notice friction, don't just have it fix the code. Have it hardwire the lesson into its DNA. Tell it, update the rules you just learned into the CLO du it fail. This way, that exact same mistake will never happen again in any future session. Another quick quiz. Since Cloud by Jom and D is so useful, should I just cram my 50,000-word architecture doc into it? Macro. The answer is B. It's best kept under 200 lines. Rules that are too long not only waste tokens, but they also cause the AI to lose focus and start hallucinating. What if your project is incredibly complex and 200 lines just isn't enough? Let's take a look at the advanced tools of 2026. For solo devs, there's an open source tool called Code Syncer. It takes the AI's decision logic and writes it straight into code comments using special tags. Because the AI reads the code every time, binding the context directly to the code ensures that the memory is never lost. At the enterprise scale, we have multi-agent systems like Gastown. It has a mayor AI responsible for coordinating dozens of smaller AIs. Under the hood, it uses Git trees to persistently save every single state. This is the ultimate form of enterprise AI memory in the future. Just a quick heads up. If you're using incognito mode, the chats with the little ghost icon, no matter how many great things you teach it, none of it will be logged into global memory. It's great for testing sensitive data, but don't count on it to help you build up project context. We're wrapping up, so let's summarize a few best practices that will yield immediate results. Never write a wall of text for your instructions. Keep them highly structured, clearly define its role, provide specific constraints like forbidding the any type, and dictate the output format. The more specific your instructions, the more stable and compliant the AI will be. Oh, your knowledge base needs regular housekeeping too. Don't just stuff every garbage file into it. You must regularly delete expired documents. Also, whatever you do not ask the model, "What did we decide yesterday?" This easily triggers hallucinations. You need to write your decisions down in actual documents for it to read. Let's do a quick recap of today's core vocabulary. Projects are global workspaces. Claude Bod Ben is your explicit rulebook. Auto memory is the implicit memory, where the AI automatically takes notes. And all of this exists to solve context loss, the problem of losing your context. To sum up today, the upper limit of your AI productivity is no longer determined by how smart the model is, but by your ability to manage context. Stop doing repetitive work. Before you log off today, go create a CL_out_backed file in your project. Write down your working standards and let AI truly become your long-term asset. See you next time.